Fantastic. Thank you so much, Jorge. I appreciate it. Hello, everybody. My name is Nathaniel Quist. This is a nice scruffy picture of me. I have like more hair than I do now, but going for the bald look now. I'm a senior threat researcher with Palo Alto Networks. I work in conjunction with Unit 42. I'm as part of the threat intel aspect side. My day-to-day job actually comes from the Prisma Cloud side, so completely cloud focused, completely looking at what are those threats that are facing the public cloud, where do they come from, and how does that work? Ties into the Unit 42 aspect from the intelligence perspective, as in who's doing that and why they're doing what they're doing and what we can glean from that. So it's kind of some of my background there. I'm a huge fan of anything puzzles. So if you give me a puzzle or something complex, it's like I just have to like break it apart and figure out what all those pieces are. Right down here on this little table, which you can't see unfortunately, is a whole bunch of puzzles, like wire puzzles and wood puzzles and math problem puzzles and just all that kind of fun stuff. Just love taking things apart and figuring out how it works. Also really into RC helicopters. Just the trying to get my bearings and confidence going for like all those inverted flips and twirls and tornadoes and things like that. It's an awful lot of fun. A little bit of a hobby nerdist sort of aspect there, which is a great amount of fun. Twitter, email, LinkedIn. Please feel free to reach out in any one of those methods. Happy to communicate. I always try to respond relatively quickly. So looking forward to any questions or comments or anything like that coming up. So within this presentation, I'm going to focus on kind of two aspects. One is going to be the cloud threat report that my team put together, which is the cloud threat report, which is essentially the state of the cloud that we see right now. And we focus in on very specific issues for each iteration of those reports. They come out twice a year, first half, second half. We did have to change the naming convention a little bit because we used to call them spring and fall. However, when it's spring in one half of the world, on the other half of the world, it's fall. So we ended up just going first half, second half on those particular aspects. Within this report, specifically, we looked at identity and identity access management and how that is used within cloud and how it may be manipulated or misconfigured in some aspects. So that was the main focus of our report. In our previous report, we looked specifically at infrastructure as code for cloud environments. So that'll be like your Terraform, your CloudFormation templates that allow you to dynamically scale environments, quickly as demand grows for those particular services. So we looked at misconfigurations within those type of templates and things of that nature. But within this one, we again focused specifically on the identity aspect. I'm going to round the presentation off with a specific look at something we allude to within the cloud threat report at the very end. It's mostly the actors that are targeting those cloud environments. And I chose to look specifically at this group called Team TNT and a new tool they created called Black T. And then there's a little bit of mitigation. How can we stop these things from happening in your cloud environments or other cloud environments, and give you some pointers for those things. So first off, the reason cloud identity access management can be very challenging is that because cloud is very complex. It can grow and shrink depending on demand, depending on those resources that are required at a specific moment. When you have one cloud account, it's actually not that hard, right? You can grab your mind around it. It's like we need to have a specific type of roles. We need to have DevOps people. We need to have builders and stagers, perhaps QA environments, things like that. Each one of those particular roles will have a specific set of permissions that are required for it, and a specific set of policies and trust policies that those roles need to have. Within that one environment, probably not that big a deal, but as soon as you start scaling out to 2 or n number of environments, it can easily get very complex. And how those images, those particular images or templates that you use to create one cloud, due to the scalability of the cloud, you'll often find that exact same misconfiguration within one cloud to the next cloud to the next cloud to the next cloud. So you might just be pushing out misconfigurations across all of your cloud environment, which is what we would hope to avoid. So this is kind of shows a little bit at scale of how complex the cloud can become relatively quickly. So within the report, we looked at red teaming a specific environment. This is something that is pretty new to Unit 42. It is not something we do. So we don't, Unit 42 is a threat intelligence gathering organization, and we share threat intelligence about malware samples, about specific types of signatures that you can use to detect other organizations or other groups that are attacking specific environments. So red teaming isn't something we normally do. However, we were presented by a client saying, hey, we would like you to look at our cloud environment to see if there is something in it that may be amiss. And we're like, well, this is an interesting take. We haven't really done a lot of this. There's a lot of real world techniques that we can use, that we can go into and just see if we can find something interesting. And to our amaze, and unfortunately to their chagrin a little bit, is that we found that we were able to actually compromise that cloud environment really quickly, like within just a couple of days. We were able to gain entire access to the whole thing. And this was a very mature organization. There might be some questions about size and things of that nature. It was very large, very mature, multiple clients, 500 some users, thousands of permissions, things of that nature. And they took security very seriously, and we were still able to find a way through it because of identity. So this first one, and this is one that Jorge alluded to earlier, is we first took two methods to look at this particular attack or particular environment, and we found two attack methods that were successful. The first method was an outside-in approach. We didn't have any initial access to the cloud environment. We didn't know anything about what we may find or even credentials or anything like that. What we found is we were able to compromise AWS's assume role feature, which allows a service account or a user to request access to a particular environment or a particular environment within the cloud. And then that service, if authorized, will give that user or that requesting service a temporary account credential for that particular environment. Although within our particular look within this environment, they were an AWS shot. However, the technique of performing this doesn't necessarily have to focus within AWS specifically. It can branch out to other clouds like Google Cloud or Azure or even Alibaba to a degree. Anything that allows for the use of short-term credentials in order for services to authenticate to other services within that cloud environment. So even though we're focusing specifically on the assume role feature, doesn't mean that it can't also pass through other aspects. So just a little caveat there. So kind of how this works, this is a pretty high level way of going through it, so we'll just kind of step through it here. As you can see here that our attacker, our researcher, is outside of our particular environment. And it was through the process of reconnaissance, it was through the process of investigating what we can find from other third-party sources or repositories, specifically GitHub, where we were able to find potential role names and what you can consider usernames within cloud environments. We were able to find role names that may be used with that environment. Once we found that role name, we just simply requested access to it. And we did this with an unauthenticated, an unauthorized AWS account that was unauthenticated to that client environment, and we just requested permissions. Due to the misconfiguration, we were just granted access because they didn't have that locked down specifically. Once we were granted access to that environment, we could step into that cloud environment, and then we were starting to enumerate the processes and the token permissions and everything that particular user role had available to it. In this instance, we were able to see that we had access to EC2 environment or instances. We could see S3 buckets, and we also had access to their key management service, which allows users or services to encrypt or decrypt particular services. So we started enumerating the aspects. We specifically focused on S3 because S3 is a good source of information that we might want to look into. We saw that we had access to S3 buckets, however, they were encrypted. So at first we're kind of like, oh, we're encrypted, we can't see them. But we remembered that we had key management services with the account, so we just decrypted the information within those particular S3 buckets with the KMS keys that were actually associated, that were allowed access by that particular account. Upon decryption, we saw service credentials that we could find in there. We saw access to other source code repositories like Docker Hub or some of their certificates and things of that nature. So that allowed us to quickly jump out into those other third-party sources that also contained other information, as you can imagine, service keys, credentials, things of that nature. And that was the length that we could go to with that environment. So looking specifically at the misconfiguration itself, if we look at the weakness behind it, we see in the trust policy in the top left here is that when you're looking at the AWS trust, you see that the principal account is AWS all, okay? And that means every account could assume a role within that environment. And you can see in the action assume role as that particular aspect. When you go to the permissions of that particular, so now we're in the top right quadrant, with permissions policy, you can see that these are the aspects that we actually had access to see. So we could, create routes, delete routes, we could see routing tables, we could see associated addresses. And then you also see that the resource section there is, again, it's an apostrophe wildcard, which means that all of those resources we could see within that environment. But here's where the true misconfiguration was. Each one of these roles, and you can see that there were multiple, and these spanned across multiple cloud environments, is that the trust identities for this particular role were any account. You can again see the account being anything. So that was the real misconfiguration with this environment, is that we were able to take an unauthorized account outside of this particular cloud environment, not knowing what they would have in their environment, but doing some recon and figuring out what type of role names they would use. And we guessed essentially these role names here. We just simply use the assume role feature, and we were able to gain access to those environments. So the result being that we were able to access sensitive data, including source code and certificate keys, and the credentials there within, and allowed us to jump to other third-party sources. The second attack method would be considered an inside-up approach. So we had some access to the environment. In this case, we had a developer account, and it was restricted and didn't have any access supposedly outside of that particular environment. We were able to take that account, we were able to move laterally within that environment, then escalate our privileges outside of that environment, and then we were able to hijack specific admin accounts and then gain control of the environment. So again, in the same way I did in the previous aspect, just kind of a quick little rundown. Our attacker researcher is inside of our developer area, and we were able to, obviously enumerate things. We could create EC2 instances, RDS, whatever a developer could do, we could also do as well. We started looking at the permissions that this particular role account had, and it had access to several different types of roles. In this case, there was a single flow logs rule that was created by the client. It was not AWS's standard flow logs permission set. However, this was created by the client themselves, and inside of that, again, they had a nice little asterisk that said anything to do with flow logs, we want our developers to be able to use. When we enumerate the flow log permissions that this particular user had, or this particular account, we saw that there was a flowlog.admin on it. So that just made us wonder, it's like, wow, this flow log actually has admin credentials within it. What would happen if we created an EC2 instance and passed that particular role to that EC2 instance, and then see what that EC2 instance then had access to? So that's exactly what we did. We created an EC2 instance, we passed the role, the flow logs with the admin permissions to it, into that EC2 instance, log into that EC2 instance, and then start enumerating your permissions and your credentials from there. We saw that we were actually able to see all of the administrators within the AWS environment itself. When we were able to see those administrators, we were also able to grab their access ID keys and their secret keys, and that allowed us to hijack essentially that administrator account, which then allowed us to then be able to create new IAM policies. We could create new roles, create new environments. We had full control over that environment. So in this instance, it was the pass role feature that was the misconfiguration. And here's a quick little look behind on this one. You can see within the development account policy, you had a series of actions that were available to you. Again, you can see that we had EC2 instances. We could terminate those. We could bring some up. We were able to get different IAM policies that were permitted within only the development environment. And we're also able to pass roles. And then also you can see we had KMS, we had some S3 access, and then some SDB access as well. And again, you can see that we had resources, were all of those resources within those particular permissions. So when we start enumerating the roles that we had for that environment, you can see here that we had EC2, we had events, spot patches, things of that nature. When we start looking at the permissions of those particular rules or those roles, you can see here, and it's grayed out, but right up in here, you can see that there was an admin's permission within that, and that would be those flow logs that I just mentioned. We essentially use the pass role feature, attach it to that EC2 instance, and then we were able to escape that environment. So again, that was a complete and persistent administrative access to the entire cloud infrastructure. And again, being able to take those AWS access IDs that we gained from that administrative user, we were able to then hijack that account and create what we wanted. It's an important point because what I'm going to talk about here in the section after this next one is could those actually be used by malicious users? So this is kind of a little bit of a segue from the kind of overall talk, but I think I left it in here because it's the state of the cloud that we see right now. These are results that from our investigation and our research of what the cloud is and how the cloud is configured currently kind of gives us an idea of where we could possibly expect other types of risks and alert risks and compromise in the future. So focusing specifically on identity, and some of these are actually kind of scary, is that when we were looking at specifically Google Cloud and we wanted to look at the VM instances that were created in it, we found that 62% of organizations worldwide used Google Cloud VM instances running under administrative rights or root privileges. Obviously, it's just like a best practice. It kind of makes you, raise your eyebrow a little bit. But this is a state that we're seeing in the cloud that's relatively frequent. It's not on this particular slide, but in the same kind of token, we looked into Kubernetes clusters and the containers that are running within particular Kubernetes files, or specifically YAML files. We saw that about 24% of YAML files or Kubernetes clusters will be running that particular container with root privileges. Not a very high number, but it is prevalent. It's a thing that happens in our environment. So locking down those admin rights for particular instances would be key. Moving over to access keys, kind of almost in the same, almost hand in hand, not exactly, but almost hand in hand with passwords, is access keys are the passwords for your cloud environment. Being able to have properly authenticated access keys, that you're able to ensure the integrity of those access keys is pretty critical for cloud environments. We found that 68% of cloud organizations are actually using access keys that are older than 90 days. While this may not inherently be bad, maybe you have a good lockdown posture and nothing escapes. What happens if something does escape? We focus pretty heavily within the Cloud Threat Report about GitHub repositories and what we can find from there. And you can find access keys in GitHub repositories that were just accidentally part of a particular source code. Those access keys will be leaked during that aspect. So being able to ensure your access key longevity and make sure that it's properly secured. If they get associated or leaked in your environment, you can't necessarily guarantee the confidence or the work of those keys will actually keep your environment safe. And the final one here is the scariest to me, honestly, is when it comes to multi-factor authentication. We found that only 24% of organizations are actually using multi-factor authentication for their root AWS environments. So if you actually had admin rights to that AWS environment, and not having multi-factor authentication is just is a large red flag. In this instance, you can see that about 76% of organizations didn't have multi-factor authentication enabled. It's a little bit better for the AWS IAM roles, like the standard user. About 47% of AWS users we found did use multi-factor authentication. But again, that's still just a little bit less than half. And I think that pushing harder for that multi-factor authentication for all roles and interactive logins with those cloud providers is it's a big must. Grouping together some of the things that we looked at, specifically logging and then also encryption. I'm going to kind of jump through these a little quicker, but it kind of shows you the state of where we are within cloud environments, specifically for storage and some of those aspects. So S3 buckets, Azure blobs, things of that nature. Focusing specifically at AWS S3 buckets, we found that 71% of organizations worldwide did not have logging enabled on one or more or all of their S3 buckets. So an S3 bucket that just doesn't have any logging, don't know who's walking into it, don't know what's being moved or added or anything of that nature. Azure was in the same boat. Azure blob storage, only 73%. 73% of organizations worldwide, again, did not have logging enabled for their Azure storage blobs. Pretty concernicus in that aspect. When you pair this to the top right over here with versioning, versioning being able to see when an item within a particular bucket has been altered and then how it was altered, and then could you revert back to a known good state if that was, say, bad. We found that 63% of organizations that are using cloud storage are not enabling versioning with that environment. This, again, it gives the aspect of, let's say if a cloud environment or cloud storage were to become compromised or even have ransomware go through that particular cloud storage, you would not be able to revert to a known good state if you didn't have versioning enabled. And then if you didn't have logging enabled, you wouldn't even know it was happening in the first place or when it happened. So that's unfortunate. S3 encryption. So if you look at AWS, for their S3 buckets in their EBS buckets, which EBS will be that elastic block storage that is attached to your whatever instance you're using. We found that 67% of organizations and 65% of organizations, respectively, are not adding encryption into those particular storage buckets. Now, this is just one or maybe more of those particular instances in those cloud environments. But again, it's not. We're seeing that it's a common trend that encryption is just not first and foremost on the minds of developers, unfortunately. I do want to put a caveat in here specifically with AWS in response to Microsoft Azure or Google Cloud, is that Azure and Google Cloud both enable encryption for their storage containers or storage resources by default, where AWS, you have to opt into it. So you should, so it is something to remember. You could go into Azure or Google Cloud and turn off encryption if you wanted to, but by default, that encryption is already enabled. So if you're running an AWS shop, please ensure that your those particular storage resources are indeed encrypted. All right, now on the kind of the fun aspect for me is looking specifically at who is actually attacking cloud and how they would be attacking cloud. I'm focusing specifically on Team TNT and their tool is called Black T. So a little bit about this, I think they're really proud from if I could look into the minds of the creators of Black T and Team TNT. I think they're very proud of Black T because they make this really fancy board and there's other text underneath it that has a few expletives in it. So I just decided not to bring those in. But they're, they went away for a little bit and now they're back, and they're back in a big way with Black T. So it's kind of funny. They're very, very proud of it. And I think they should be, because their tool is, while relatively script kiddie-like, and because they're just stealing code from other places and just putting it in there and just letting it run. They put a lot of time and effort, and you can see a lot of work and fun little clever things within their scripts that I think they're really onto something here. So just kind of a quick overview of Black T itself. It's a new tool from Team TNT. Some of the key features that it has are worm capabilities. While not new to Team TNT, Black T did a couple interesting things. Is that they have 3 distinct scanning tools that go through it, and they're focusing specifically on Docker and Redis services that are exposed to the internet at large or within that particular local environment that they're able to compromise. They go in, and this isn't really new for Black T as well, or Team TNT, but they go in and they disable other miners. So any of those other cryptocurrency miners that are in there, being like, say, Rock or Pacha, or in Team TNT's aspect, Kinsing, which is a big adversary, I guess, if you would, for their environment. They go in and they disable a lot of cloud miners. What was interesting about Black T is that we were actually able to find 4 new crypto jacking families that we didn't actually know about before. So that was kind of interesting. That's like, oh, we didn't know about these. Let's see if we can get some of these indicators and see if we can find them. I've been able to track down a couple of them. Some of them it's hard to find them because they use a lot of. I'll show you here in a little bit, but they use a lot of obfuscation. They make miners look like other miners pretty regularly, so it makes it very difficult to specifically say this one is the one that they were stopping. Other interesting things that Black T does is they're really heavy on credential scraping. And again, this isn't necessarily new, but Team TNT and Kinsing and a couple others have already been known to target AWS credentials in their environment. Black T takes it a little bit step further, and they have put Mimi penguins into their particular into their scripts, so they can start grabbing some of those plain text memory credentials from those environments. But I'll dive into those pretty more in the next few slides. Docker Hub, they have a few Docker Hub images. Looking through the scripts, we were actually able to identify that Docker Hub, and we requested the Docker Hub remove it, which it was successfully taken down. And I think that, I think I would be disappointed if I was a bad person and my Docker Hub image was taken down almost as quickly as when it was put up. So that's pretty cool. But anyway, they use customized XMRig software, just specifically targeted towards their particular their variant. If you want more information about the information that I'm going to relay further into this blog, take a look at the Team TNT Black T report. It's on the Unit 42 Palo Alto Networks.com/cloud website or blog site. So please take a look at that. So diving in specifically to the functionality of Black T itself, is that they use 3 scanners. They specifically use mass scan, which is I think their go-to favorite one. They've historically used, and they still use it within this one, is PN scan. And they also introduced a new version called zgrab. Zgrab is from the creators of ZMap, so mapping the internet sort of aspect. However, zgrab is made within Go. And I think that's a big, a big notch that we can put in there, is that Go within cloud environments is a very cloud-friendly language. It allows for concurrency of operations, so you're able to do multiple operations sequentially or in parallel, as we know, where we have to use threads or something within Python. But Go is very efficient in how it works, how it makes that worker run within that particular script. Now, again, these are just essentially scripts that they're just scraping together and dumping out, but it is important to know. I think this is the first instance of zgrab. I think they were kind of trialing it out, because if you look at the GitHub page for zgrab, is that zgrab version 1 that they're using in here has actually been deprecated. It's not used anymore, and they've subsequently ZMap has gone to a new version of zgrab 2.0 because there were performance issues, and it would hang pretty often within the first version of zgrab. So I think it was a trial. We might start seeing that zgrab 2 is pulled down. So keeping our eyes out for new versions of zgrab being used by these actors. It's also important to note that they're focusing specifically on different types of NICs OSs. So they're looking at APT, they're looking at APAC and YUM, and so all your flavors are represented. And they, again, mass scan is their big heavy lifter for their scanning operations. So it seems kind of fitting that they actually get into it. So some of their other worm functionality I mentioned earlier is that their targets specifically are Docker daemon, exposed Docker daemon APIs, and also Redis servers. You can see that specifically within the examples here is that they're specifically looking at those Docker daemon ports 2375, 2376, and they also look at the Redis servers 4243 and 4244 to see if they can find those particular those exposed systems and then compromise them. What is interesting within BlackT is that they're using a new port, which is 5555. 5555 is commonly, defaultly associated for some types of mining software, specifically like XM rig and things of that nature. Although we don't necessarily see that those particular ports are used super often within cloud environments that are doing mining operations, it is interesting to see that that they're bringing this other port in here where they hadn't before. Doing a little research into that port, there are instances where IoT devices, Android IoT devices, do actually listen on that particular port. So it could be possible that Team TNT is looking specifically for some of those Android IoT systems. Again, kind of a mystery, but they're looking for it. So that's something interesting. They also do two different kinds of scans within the environment, two kinds of network scans. They do their local Docker scan, so as soon as they find an exposed Docker, they'll have that Docker go and scan its local network to see if it can find other potential Dockers or Redis servers that are running. This one also does a random scan as well, so it will look across very large CIDR 8 network ranges, and it'll do scans for that as well. So they're really looking on getting that scanning out there and looking for any other low-hanging fruit that they can find. Into the disabling of other XMR miners, they have a full kind of side script called main clean app, and it goes through and it removes what other types of miners you can see. There's a whole list of them, as you can see in here, specifically looking for Docker as well. It was interesting. This WeDoc 26117 is actually still a Docker hub that is up. I was just checked it this morning and it's still up. But it only has about 3,500 or so downloads, so it's not super prevalent, but it's up there and they're actively looking for removal of that. Kind of fun. Number of other Docker containers that they're looking for. Other things it also does is it also cleans up their own Docker containers. Any Docker containers they have had from previous versions. You can see this Hilde Team TNT, which Hilde at teamtnt.red is actually an email address for the actors themselves. So they actually have other Docker files that they've used as well. It also looks through other ways to clean up other processes. They specifically, that is Team TNT, uses specifically Monero Ocean.stream as their public mining pool. So anything that's connecting to Monero Ocean, they'll also turn that off. And you can see here within the slides itself here is other miners. This is why they're relatively hard to find in some aspects, is they do a lot of obfuscation of names, right? So they just have surnames and then they go from there. So there's a miner called Docker Update or Docker Backup miner. So which it looks like a Docker, but it's actually a mining system. I mean, Redis miner, pretty nondescript. We had never heard of Cruxworm before, so there's one of those new ones. They're trying to upsert the audit D, functionality within Linux systems. So there's a miner named after that. You can kind of see the aspects of what they're using for naming conventions to get some of these miners. But it'll go through and it'll try to remove anything that it finds associated with these particular names or where those type of miners would be saved on a system. So kind of neat there. Once it's kind of gone through and cleaned everything up, then it goes and cleans and it updates some of the files. It'll update some of its own tools or tools that it may need within its particular environment, and it'll remove other aspects. So it'll get rid of all the temp file systems that are in there, any cron jobs that are running on that particular NIC server. It'll wipe those out. It even cleans up all of its old code or its old rigs if it re-compromises a system that's already been on before. You can see that specifically here with this crypto rig. They named the square brackets crypto pretty regularly for the name of their mining services. Interesting, it also goes in and it removes all of the previous scanners that it has, minus mass scan. TNT scan is a different version of mass scan that they use for specific old stuff, old scanners that they may have had in environments before. So it's kind of interesting. One of the behavioral IOCs that Team TNT is known for is they go in and they change some of the processes to make them customized for their own uses. So they'll change wget to TNT wget and TNT curl and things of that nature. So it's got some kind of an interesting kind of thing there. So then it sets up. So once it's gone through and it's kind of enumerated all the stuff, it actually does one more step for this, but I'll get to it in a second. It goes in and sets up its XMR rig. This is a very common approach within their scripts, is they use a lot of base64 encoding for their environments. So you can see that they're setting up their XMR and they label it nice and easy there for you, set up XMR, which is really cool. So again, there's kind of a it's a script kiddie like sort of aspect, but you can glean some interesting things from it. First off, is that we can see that we have a Monero wallet address here, and I'll go into what was found that in a second. So that way we can actually say, we know it's from Monero Ocean, we have a wallet address, so we can go to Monero Ocean, we can see how much currency they've mined in that particular time, whatever it is. So breaking apart their base64 here, they do no hops, so it stays active even when that system's, when that user's particularly logged out of that particular system. And you can see that they're downloading their own XMR rig, but they've named it SB or SBen_U. So, and then they rename that just to SBen. So that will be the name of the XMR service that you'll see running within systems that they've taken over or compromised. So pretty basic setup right there. Just pull it down and put it in the right directory, and off we go. And they'll activate it here in a second. This is also interesting. The second one here is they actually started a new Docker process. So they'll go out and they'll reach for their new Docker particular image, and then that one will start up. Given it's they'll update the system, install new stuff. I mean, your typical Docker types of operations. So pretty neat stuff there. Get some information, at least what it's looking for. So the cool thing is, so we found some Docker hubs. They specifically, we referenced earlier, Hilde Team TNT. That profile no longer exists. And then they also, within Black T, they used one called Curito 666, which actually has, if you do some kind of intelligence searching just on that name itself, there's several anime characters and users on that probably have nothing to do with Team TNT. So it's interesting they chose that name. I don't know exactly why, but something interesting there. And you can see that they within that script right here, you can see that they're specifically pulling down that particular image to start with. We did notify Docker right when our blog was being published, and Docker Hub confirmed that that particular image was taken down on the 16th after that. So here's a little bit of look at the address itself. So when our blog was reported, when it was released on October 5th, this is what we saw for the last 3 days worth of activity. You can see that they only had 5 workers active at the particular time, but a couple days before, they had probably about twice that, so maybe about 10 or so workers going on it. They hadn't grabbed a whole lot of money yet. It was only like a 0.08, almost 0.09% of the Monero coin. Not a lot, about 10 bucks. So nothing really crazy on that one. But we reported it. Docker Hub took that particular image down and then waited for all the cooldown to go by. And then by November's time, there was no workers going. It was pretty much dead in the water. So, and they only had 1.5, which is, again, not a whole lot, like 25, 30 bucks. But it kind of goes back to, they put a lot of effort and time and energy into building this particular type of script. And we found it within, 2 days of it actually being dropped. We had it reported on within the following week, and then the image was taken down the week following. And then, it just drops, ceases and desists. So hopefully it's a good win there. Stop those people from doing what they're doing and kind of moving on. But this next section here, this is what it ties back into the identity aspect that I got to at the very beginning, is looking specifically at identity. Black T had a very impressive way of, well, not really impressive. It's just, it's interesting to me that the miners are actually looking for this. And they do this before they even start doing their mining process, before they even download the miner and start that process off. They grab everything they can from that system, just grab all that sysinfo and stuff like that. But what they also grab are the .aws directory. Inside of that particular directory, you can see here that there's credentials. Sometimes there's a config folder inside of that. And inside of those credentials, if they were on there, that particular compromised system, you have your access ID or your access key that are part of that associated AWS environment. They package all that off and they send it up to their control server up there. And this just allows them the ability to do several different types of post-exploitation sort of attacks. Kind of like what we did within our red team attack, is we just had an access ID key and maybe a secret key that we were able to glean in some aspect. We were able to enter those particular roles and then start using them. Maybe see what type of resources they had available to them. If there were some sort of identity misconfiguration within those trust policies, what have you, being able to lateral out of that, move up, escalate. I mean, it just increases quite a bit the amount of damage that a particular set can use. Kind of goes back to an older adage where if you compromise a system, that's okay, especially in a cloud environment. You can compromise a system, you can just turn it off, return it back on, and that system's kind of clean, it has that fresh snapshot. However, if you're able to compromise and gain access to a cloud account, now you actually have a little bit more persistence with that environment, and you can do more. That attack surface has increased. Interesting thing that Black T does is reference Mimi Penguins. If you're not familiar with Mimi Penguins, you might be familiar with Mimi Cats. That is a service that looks at memory aspects within a Windows environment, and it'll pull out things like credentials or passwords, things of that nature. A lot of other things Mimi Cats can do as well. This is Mimi Cats, but for Linux environments, so they call it Mimi Penguins because of, Tux is awesome. So this one's pretty simple. Again, pretty script kiddie-like. Pulls down a particular, get passwords tar file, does a little unzip, starts operating the permissions. Again, puts it in the exact same directory or creates a new directory, which is ... and then sends that information that it gathers up to its third-party system there. Uploads that service, and then deletes those files on it. So hopefully if you had some sort of logging operation on those particular systems, you'd be able to see a lot of this activity. It's not very stealthy. And that's an interesting thing with cloud miners in general. They're not stealthy, they're very apparent. I mean, they're not encrypting anything. The most they'll do is do a little base 64 encoding and then they call it good. They're not really worried about people finding them, which I think is kind of, it's ballsy. So pretty cool. But getting those aspects, if we go back to the previous aspect where cloud environments get more complex the longer and longer they're in the environment, you can see how if you were able to, or if these actors were able to get access to AWS credentials in that cloud environment, how many other environments with that within that organization would they also be able to propagate to or have insight or a foothold into? So brings a couple of questions that we want to think about. So moving on to mitigation. This is kind of a best practices. I know that my Prisma Cloud logo is right there. Not super trying to sell you on Prisma Cloud. I mean, pays my bills, but these are just best practices that any kind of cloud native security platform, being that Prisma Cloud or any of the other ones that are out there. I mean, being able to look at some of these aspects or being able to harness and alert organizations, or even in some aspects, solve some of these basic security things, makes it a little bit easier to use. So just kind of going around the wheel here, a lot of things to really touch upon. Mentioned here in the top left here, the minimize the use of admin credentials. Especially within those Google Cloud VM instances that are running underneath admin rights in those environments, minimizing those aspects, completely. This kind of moves across over into regularly rotating your access tokens or your access keys. Again, we don't necessarily want our access keys to be used in excess of 90 days. If you're pretty confident that you can manage those things effectively and they're not going to leak, then I want to know your secrets. Because they do leak, they will leak over time. So rotating them just helps ensure the integrity of your environment. Access keys, I can sympathize in a lot of aspects because rotating access keys is a process. It is a convoluted process. But moving something in, like say a source solution or something like that, to help you automate that process would be recommended in that particular aspect.
Yep. And so, sorry to jump in, but we are a bit over here. And I did want to cut you off on the mitigation part, because like that's arguably one of the most important parts. But
super important.
But no, this is awesome. We did provide the slides for everyone. If you don't mind, if you can head over to Discord and we'll just do Q&A on the main track there. But really want to thank you. This was awesome, and especially that you again, giving back to the community. I know that this was a report shared among a few, and then has been opening up, and you're giving back. So really appreciate all of that.
Yeah, most certainly. Anytime, any questions that y'all have, please let me know. I love it.